In this lesson, we will explore the properties of sine and cosine graphs. Let's start with the graph of y equals sine of x. And keep in mind that x is an angle. So for instance, we could calculate that the sine of 25 degrees equals, if we did that on a calculator, it'd be about 0.4226. So the x is an angle, and the y is the output here, or in this case, the decimal. Now, normally in sine and cosine graphs, the x-axis is not labeled in degrees. Normally it's in radians, so this x-axis here is labeled in radians. A couple of things to notice about the graph. It does continue forever to the left and to the right. And notice it oscillates between +1 and -1, and just keeps repeating that. And it finishes one repetition of its pattern in 2 pi radians, and then it just repeats it over again. Let's dive just a little bit deeper into where those where that graph came from. So x is an angle, we'll be using radians, and y is the output. Now remember, the unit circle is very helpful because the x-coordinates of the point around the unit circle are the cosine of x, and the y-coordinates of the points around the unit circle are the sine of x. Now, since we're graphing sine of x here, we won't be looking at the x-coordinates of these points around the unit circle. We'll be looking at the y-coordinates. So for instance, at 0 radians, the y-coordinate is 0. So we have the point 0, 0 on our graph. That means when we have 0 radians, the sine of x is 0. Now let's go to pi over 2 radians. Pi over 2 radians, the sine of x is 1. At pi radians, the sine of x is 0 again. At 3 pi over 2 radians, the sine of x is -1. And 1 full circle is 2 pi radians, and the sine of 2 pi radians is back to 0. So this is not only 0 radians, but it's also 2 pi radians once we've gone around the circle a full time. And if we took the time to graph these other points, we would get this nice smooth curve. I'd like to highlight a few of the properties here. The domain of the sine function will be from -infinity to +infinity, because remember the graph went forever to the left and forever to the right. And the domain has to do with x values. Now the range has to do with the y values, and those were oscillating between -1 and +1. And the period, that's the distance for one full cycle, is 2 pi. Very similar graph for y equals cosine of x, but notice that it does not go through the point 0, 0. It goes through the point 0, 1. But it does finish one complete cycle in 2 pi. It goes forever to the left and forever to the right, oscillates between +1 and -1. And we can use the unit circle once again to help us graph some points. Now this time we're graphing y equals cosine of x. So around the unit circle, we'll be looking at the x-coordinates of the points around the unit circle to help us graph this. We'll be ignoring the y-coordinates. Those helped us with the sine graph. So remember, these values along the x-axis are the radians of the angles. At 0 radians, the x-coordinate around the unit circle is 1. So that'll be our y value. At pi over 2 radians, the x-coordinate around the unit circle is 0. At pi radians, the x-coordinate around the unit circle is -1, so that's our y value. And at 3 pi over 2 radians, the x-coordinate is back to 0. And one full circle, or 2 pi radians, the x-coordinate is back to 1. So some properties of the cosine function. Once again, the domain is between negative infinity and positive infinity. The range is between -1 and +1. And once again, the period or the distance for one cycle is 2 pi. Okay, we can translate or shift the sine and cosine graphs. To do a vertical shift, we just add a constant after the sign of x. So when d is positive, we shift the graph up. When d is negative, we shift the graph down. So here the graph of y equals sine of x is shown. Now we're going to graph y equals sine of x plus 2. So everything shifts up 2. So we could start over here with this point. The new point will be 1, 2, up 2 from there. Up 2, up 2, and so on. Now we get hints about the horizontal shifts, or the left and right shifts, for sine and cosine graphs by looking inside the parentheses. Now this one is the backwards one. When we're subtracting inside the parentheses, that's when we move to the right. When we're adding inside the parentheses, that's when we move to the left. So on this one, we have the graph of cosine of x shown, and we're going to graph y equals cosine of x plus pi. So since the plus pi is inside the parentheses, we're going to move left pi radians. So notice on the x-axis, to move pi units to the left, we'll have to go 2 grid marks to the left. I've highlighted the points that I'm going to shift to the left. So this point here, we're going to move left pi radians. So here's half a pi, and here's a full pi. So I went from here to there, to the left pi radians. I'm going to move pi radians to the left from this point. So 1, 2, there we go. So now I'm on to this point here. I'm moving left pi radians. And from this point, I'm moving left pi radians. And finally, left pi radians from here. Let's do a sine graph now that has both a horizontal and a vertical shift. So in this one, we're going to move left pi over 2 radians and down 2. Now notice the scale here. So 1 full hash mark here is pi radians. So I'm going to be moving half of that. Let's start here at this point. We're going to drag it left pi over 2 radians and down 2. I'm going to move this other point left pi over 2 radians and down 2. And there's my new graph. I moved it left pi over 2 and down 2. Now here in this cosine graph, I'm moving to the right pi over 4 radians and down 3. Okay, let's look at the scale. A full grid line is pi radians, so I'm just moving 1/4 of pi radians. Right, moving to the right and down. So let's start with this point. I'm going to go to the right 1/4 pi and then down 3. And take the other point and go to the right pi over 4 units and down 3. And there's my new graph. I move to the right pi over 4 radians and down 3. Hope you found these examples helpful. This is Mr. Ela, signing off.